Okay, so in this video we want to look at L'Hopital's rule. So L'Hopital's rule is used to evaluate certain types of limits. So the theorem states that if the limit as x tends towards some point p, could be 0, could be infinity, could be 10, of f of x over g of x is indeterminate. Now what this means is it could be 0 over 0, infinity over infinity, minus infinity over infinity, and so on. 1 over 0 is not indeterminate. 1 over infinity is not indeterminate. So you could also have 0 to the 0. That's also indeterminate. So if this is the case, so if this does give an indeterminate limit, then what we can do is actually differentiate the top and differentiate the bottom and then evaluate the limit. Notice one thing here, this is not the quotient rule. You do not apply the quotient rule. What you do is simply differentiate the top and differentiate the bottom separately. Notice that also you need it to be indeterminate. It's not true just to make the limit simpler. You definitely need an indeterminate form. So let's have a look at this first example. So we have the limit as x tends towards infinity of e to the 2x plus 5 over x plus 9. So what we see is that this tends towards infinity and this tends towards infinity. So we can use L'Hopital. And so what we can do is differentiate the top, and what we'll get, so this is the same as the limit as x tends towards infinity of 2e to the 2x plus 5 over 1, which is the limit as x tends towards infinity of 2e to the 2x plus 5, but as x tends towards infinity, e to the 2x plus 5 tends towards infinity, and so the limit is still infinity here. Okay, let's look at another example. So here we have the limit as x tends towards 0 of sine 8x over 10x. Now sine of 0 divided by 10 times 0, well, that'll give us 0 over 0. So again, we get an indeterminate form. And so what we can do is apply L'Hopital. So this is the limit as x tends towards 0 of, well, the derivative of sine 8x is 8 cos 8x, and the derivative of 10x is 10. So now I can evaluate this limit. So I put x equals 0 and I get 8 times cos of 0 over 10. Cos of 0 is 1, so I get 8 over 10, but 8 over 10 is 4 over 5. Okay, let's look at this last example. So we have the limit as x tends towards 0 of x squared sine 1 over x divided by x. Now the thing that's tricky here is that sine of 1 over 0, this is something you have to be quite careful of. So even though it looks like you would get something like 0 over 0 here, I wouldn't use L'Hopital's rule as of yet. What I would do is divide so this is the same as the limit as x tends towards 0 of x sine 1 over x, and at this point I would use a new trick. I would use something that's commonly referred to as the Squeeze Theorem. So I'll cover this in a separate video, but the idea at least for this example is very, very simple. So what we'll do is we'll notice that for any x, sine x is bounded between -1 and 1. Of course, this is true because sine just oscillates. It doesn't increase. It's always bounded between -1 and 1. So in particular, what we see is that sine 1 over x is bounded between -1 and 1, because this will just change the frequency. So now I can multiply both sides by x, assuming maybe x is positive, which is fine. Then we'll have minus x sine 1 over x is less than or equal to 0, less than or equal to x, sorry. And so now what we see is that the limit as x tends towards 0 of minus x is less than or equal to the limit as x tends towards 0 of x sine 1 over x. But this is less than or equal to the limit as x tends towards 0 of x. So I've just put limits in this series of inequalities here. But now as x tends towards 0 of minus x, that's going to be 0. And then we'll just have the limit as x tends towards 0 of x sine 1 over x. But this also, well, x obviously tends to 0 as x tends towards 0. And from this, we observe that the limit as x tends towards 0 of x sine 1 over x, well, it's bounded below by 0 and bounded above by 0, so it better be 0. And that's it for this video. So just to recap, L'Hopital's rule says that if you have a limit which gives an indeterminate form, for example 0 over 0, infinity over infinity, minus infinity over infinity, and so on, then you can differentiate the top and differentiate the bottom. Not the quotient rule, but just differentiate each term individually and divide. And this gives a simpler way to compute the limit. So we saw that you can still get infinity in the limit. You won't always get a finite number, but in some cases you do. In other cases, I'd be careful of things like sine 1 over 0, at least as, or sine 1 over x as x tends towards 0. And if we're given such an example, you can try the squeeze theorem, which you just bound the function that's in the limit by things that converge to the same thing. So you essentially squeeze it between these two bounds, and since both went to 0, the resulting limit had to go to 0. Okay, that's it for this video. If you like the video, please hit the like button and consider subscribing if you're new to the channel. If you have any questions or things you would like to know, or even questions you would like to give to other students, please leave them down in the comment section down below. And in the video description, there'll be notes to accompany this lesson here. Thanks, guys.